back in South Africa. I have had a fantastic time here in the nature, looking at wild animals several times, and also have a great time with people. Very friendly and treating guests wonderfully. This talk, honestly, I'm a little nervous because it's the very first time I present this talk. I have a few slides from the previous, so I can fall back to. But my intention is now to not talk so much about technology, even if I have to do a little about that, but actually talk about the impact, the usage of it. So, the talk is about Agile and CMAT. Yeah, Agile you have heard about. How many have heard about CMAT? Okay, let's say 20%. I'm happy to be able to increase that number today, at least you have heard about it, and after today. Well, you all know what Agile is, so I'm not going to spend a lot of time on that. Some people think it is Agile is Scrum, because it's really widespread, and working with customers, we hear all the time that they are thinking Agile, Scrum, or more or less synonymous. That's more, some people actually think it's Scrum plus user stories and test-driven development. But all of us know that the real best definition is what we have done so many times, so I'm not going to talk about it. But the first lines here are the most important. We are uncovering better ways of developing software by doing it and helping others to do it. So, this is, we know, and there's so much evidence of it that we are making a lot of mistakes. Even now, when we are agile, we make a lot of mistakes and unnecessary mistakes. And we also all agree that there is no one size fits all. That time is over. But what we need, and there is a common agreement on that, this is what CMAT stands behind, is that we really don't have a foundation for what software development is. We don't have anything we can say we agree on in the software development, apart from a manifesto. But that's quite weak. It's only a few lines. In the research community, there is no common ground. In the people who do research, less than 1% of all academic research ever results in anything useful. That is just too low. We need a little bit more. We have more than 100,000 ways of developing software. No one knows who we are apart from a few of them. And we cannot really compare, even within a company, a larger company, there are maybe many different ways of developing software. Fujitsu, for instance, just to take an example, there are 27 different ways just in the UK. And people cannot talk to one another if they work within one product, because we don't have any common ground. So what CMAT is looking for is to find a foundation. One of the things they're looking for is to find a foundation for what software development actually we always do and always have. And that's where we started. CMAT actually stands for, nowadays, Software Engineering Method and Theory. And if I get time later, I'll tell you the real story, how this name came out. It sounds as as it stands, it sounds more scientific than it is. But the real core of the CMAT initiative is to come up with a kernel, the essence of software development. And one way to describe it, which is very superficial, is that it is a model of software development which is state-driven. So you actually understand where you are and where you're going. It includes the small set of things that are universal for software development. Things that we always do, always produce, always have when we develop software. It may sound strange that we, after all these years, don't have anything like that. We don't have, or haven't had anything like that. So basically, with every new methodology, every new idea, also reinvent the wheel. We get new terms for things we already have had for many years. And that means it's hopeless for people who have worked many years in the industry, learn something, and they have to switch to new terminology for no other reason than that the author of the new methodology didn't like the old terms. So that is, and it doesn't mean by any means that we don't want to see invention. We want a lot of invention, and we would actually make it easier to invent in the future. It's hard today to come up with a new idea. I'm Swedish, but the climate here is tough. At least when it's summer in Sweden. So we want it to be easier to come up with new ideas, because you don't really need to describe what already exists, what already works. Now, so we start with a kernel. And this is just a little notation for a kernel. But of course, and this kernel is actually used in projects where people feel they know how to do it, but they get help by the kernel. And I'll explain soon why. But of course, the kernel is not enough to develop complicated systems, to develop enterprise systems, product line architecture, cloud computing, software in the cloud, and so on. Systems of systems, really large systems. You need more. But these things are then added on top of the kernel. So you use kernel as a common base. But there's still there value for all of it. It's value in many different concepts. So on top of the kernel, we add practices, such as Scrum. Scrum is essentially a project management practice. You can add user stories or whatever you want. But that is not the subject of today. It's the subject of tomorrow. I will only focus on the essence, on the core, on the kernel. And I'll throw in your face, right now, the kernel. This is what has been worked on for a long time in the CMAT community, and is now being adopted as a standard. Because what we need, this kernel needs to be widely agreed. If it's not widely agreed upon, if it's my kernel, people will say, of course, well, I have a better one. They will still say that, but at least now there will be a lot of education around this kernel. So people will learn in universities. It's already being taught at many universities around the world. And of course, by people in companies adopting it, they say this is a kernel. I don't like everything, but I like the most of it. And I can add things if I'm not happy. I can add team, we say there are always a team to develop software. Smallest team is one member, but there's always a team. And there's always a way of working. It may not be documented, but there is a way of working. People work, so there must be a way of working. Now work, like a sprint is a work, a project is a work. So there are several different kinds of work, and they are all characterized by progress, hopefully. We develop software systems, and there's some kind of requirements, but requirements are not fixed. Requirements is, you can imagine, it is more like an intent. A synonym of that would be intent, but we didn't use that term for other reasons. There are always stakeholders. If you don't satisfy your stakeholders, customers, users, or people in the organization, you will not develop a product that will be happy. Finally, an opportunity. We always build something because there is an opportunity to build something. This is not documentation. There's nothing here that says how you have to do it. You can do it in many different ways, but there is one thing important about them. They represent progress. So you have, for instance, a team is usually started in a larger company by funding. You have money. Then you form a team. They don't collaborate. They don't know how to work. They may be totally strangers from one another. This is not good. And then they collaborate. So they move from state to state until they are absorbed. Like any other team, a software system is, from the beginning, there is not much. Maybe you have found a design, but in our case, we want that design to be executed, not just drawings, papers. We go on, and the software system moves from state to state. So these are things, the requirements, as I said, they are never done, finished, until you have a product too. So the requirements move from state to state too. So this is the smallest set of common things we have. But behind it is quite a lot.